In this video, we're going to go over the unicity of the inverse function, and this will allow us to define what an invertible function is. Now for the unicity, we have a little proposition which says we start with a function f that goes from a to b, and it says that if there exists a function g which goes from b to a, such that g circle f is equal to the identity over a, and f circle g is the identity over b, then it is unique. The function g is unique. There can only be one that satisfies this property. Now for the proof of this, whenever you want to prove that an object is unique, you can suppose that there is a second object which satisfies the same property, and then you show that they're both equal. It's equal to the first. So we'll do that. We'll start with a function g prime that goes from b to a, b such that g prime circle f is the identity over a, and am I going to run out of space? F circle g is equal to the identity over b. We're good. Now what I want to show is that g prime is equal to g. So I'll start with g prime, and I know that g prime is equal to g prime circle the identity over b. And I want to do this because I need to somehow bring g into this equation. So I'll replace the identity over b by this part right here. So we're going to have g prime circle f circle g. And remember that composition of functions is associative. So g prime circle f circle g, we can change it this way. But we know what this is, okay? It is the identity over a. So we can write the identity over a circle g, and the identity over a circle g is simply g. Now that we've established that g and g prime are equal, this means that the function g, which goes from b to a, and when composed with f, gives us the identity function, this is unique. And this will allow us to define what an invertible function is. So a function f that goes from a to b is said to be invertible if there exists a function g that goes from b to a such that g circle f is equal to the identity over a, and f circle g is the identity over b. The function g is then called the inverse of f, and it is written, we have a little notation for g, we write it as f inverse with the minus exponent. So remember, if we have an inverse, our proposition here tells us that it is unique.